Okay, so I'm going to go through the exam question with you. My advice is for you to go and find the question online, have a go at it yourself first, and then come back to this video to see a work solution if you're not sure how any of it worked. Okay, but the first question, so it says, an electric wheelchair powered by a battery allows the user to move around independently. One type of electric wheelchair has a mass of 55 kilograms. The maximum distance it can travel on level ground is 12 kilometers when carrying a user of mass 65 kilograms and traveling at its maximum speed of 1.5 meters per second. The battery used has an EMF of 12 volts and can deliver 7.2 times 10 to the power of 4 coulombs of charge as it discharges fully. Show that the average power output of the battery during the journey is about 100 watts. Now, I've gone through and underlined all of the key points in the question, and we're going to try and filter through this information so we can come up with the equations that we're going to use. Okay, so we've been given masses, we've been given a speed, and we're asked to work out power. Now, if I start with the power side of it, the equations that I'm thinking of whenever I think of power is my P equals IV equals energy over time, and even equals force times velocity. Because I've been given a velocity in this question, it's good just to jot that down. So that's all the ones I could potentially use. I've then been told about a voltage and a charge, which means I can work out an energy, which may help me in working out my power. So I'll jot down that equation. So I know that my EMF is my work done per unit charge. Okay, that's my second equation. Now let's think about what information we have and what we can work out. Now we know a distance. So in my mind, I'm thinking work done, well, that's energy, and work done is also force times distance. So those are the sort of equations that I'm thinking about and I'm writing down to begin with. And let's see if we can combine them to get to the point where we're working out power overall. So we've got force in our equation over here, which is work done divided by distance. Now I can find my work done by doing my EMF times my charge. So that means I can find my force, substituting in the work done, divided by distance. Okay, once I've got my force, I can pop it in there with my velocity and work it out. So let's start plugging in numbers. So we've got an EMF of 12 volts times the charge of 7.2 times 10 to the 4, divided by the distance that I'm travelling, and I'm being careful because my distance needs to be in meters. So pop that distance in there. Now I've got that. I've got my force that I can pop in here, and I've got a velocity that I can pop in there as well. So let's just work out what this force is, and it works out to be 72 newtons roughly when I type it in on a calculator. Pop that into my power equation. So my power is 72, my force times my velocity, which is 1.5. And I get an overall answer of about 108 watts. Okay, so that's approximately equal to 100. Okay, therefore you've shown it. Okay, the next part, part B, it says during the journey, forces due to friction and air resistance act on the wheelchair and its user. Assume that all the energy available in the battery is used to move the wheelchair and its user during the journey. Calculate the total mean resistive forces that act on the wheelchair and its users. So it's asking you to find out the resistive forces. Now, what it's telling you in this question is that all the energy available in the battery is used to move the wheelchair and its user during the journey. That means it must be travelling at this maximum speed that they've given you in the start. If it's travelling at a maximum speed, that means it's also travelling at a constant speed. So you know that the forces that are driving the wheelchair are going to equal the forces that are resisting the wheelchair. So the forces are balanced. Now we've already worked out the forces that are driving the wheelchair. We worked that out over here using the energy supplied by the battery and rearranging our work done equation. Okay, so we already know what the mean resistive forces are, so I'm just going to write down my driving force equals resistive force. I worked out my driving force was 72, so I'm just going to pop my 72 in there. Okay, now the next part of the question talks about the wheelchair moving on an inclined plane. Okay, so the diagram below shows the wheelchair and its user travelling up a hill. The hill makes an angle of 4.5 degrees to the horizontal. That's all shown in the diagram. Calculate the force that gravity exerts on the wheelchair and its user parallel to the slope. So as soon as you see the words parallel or perpendicular when it comes to inclined planes, you know you're going to have to start resolving vectors. Okay, and resolving vectors is breaking it down into the individual components. Now this is asking us to calculate the force that gravity exerts on the wheelchair and its user. Okay, the force that gravity exerts on anything is a weight. So if we can work out the weight force acting on the wheelchair and its user, we can then split this weight force up into a force that is parallel to the plane and a force that is perpendicular to the plane. We're breaking it down into our right angled triangles. Okay, so that we can work out components. And the component we're going to try and find in this question is the one parallel, so it's going to be my red force here. Now we just need to work out angles. And the way that I'm going to do that is I'm just going to extend my triangle out. So I've created another right angled triangle, and this will help you find what angles we have inside our little triangle. So this is my horizontal floor. This is my inclined plane here, if you imagine it on my diagram. Okay, I've just extended it down to make my inclined plane. So I know that this angle in here is 4.5 degrees. Okay, now looking at this big right angle triangle, I can see that this angle here and this angle in here are going to add up to 90. Okay, which means that this angle here in my little triangle must be my 4.5 degrees. Okay, so with that information I can then work out my red force. So my component of weight parallel to the plane is going to be my original weight force multiplied by sine theta. Okay, and my theta is obviously going to be 4.5 when I sub that in. Now, why is it sine theta? Because the values that I'm using are my opposite to my angle and my hypotenuse. Opposite over hypotenuse gives me sine theta, so I've just rearranged it and multiplied my hypotenuse across to get my W sine theta. Then I'm going to substitute in the values. Now it says that the gravity exerts on the wheelchair and its user, so I need the weight of the wheelchair and its user. So when I go back to the top of my question, I can see the mass of my wheelchair and the mass of my user. It has a combined mass of, what's that going to be, 120? Okay, so it's 120 kilograms. So it's going to be 120 times 9.81, because we want a weight and not a mass, multiplied by sine of 4.5. When I type that in my calculator, I get an answer of 92 newtons, which I'm going to write down here. Okay, so I got 92 newtons for that one, resolving forces. Right, the next part of my question then goes on to ask me to calculate the maximum speed of the wheelchair and its user when travelling up this hill, when the power of the output is 100 watts. So I know that that's what my power is going to be. Assume that the resistive forces due to friction and air resistance are the same as in part B. Okay, so again, I'm trying to find a maximum speed. So when I work it out, I know that my velocity is going to be constant, because I've reached that maximum constant velocity. That means my forces have to balance. Now, they've told me that the resistive forces due to friction and air resistance are the same as in part B. So I know that some of my resistive force is made up of that 72 newtons that I calculated there from air resistance. I then know from this part of the question, I have another force acting down the plane. Okay, so if I look at my diagram, I've got my resistive forces of 72 newtons, which I've already calculated, but I've also got a component of weight acting down the plane, which I worked out to be 92 newtons. So I know the total forces acting against my driving force is going to be the sum of these two forces. Okay, so I've got 92 add 72 gives me my total resistive forces. That is 164 newtons in total. So now I've worked out, because it's balanced, if I go back to my diagram here, because it's balanced, whatever driving force I have going up the plane, and I'll just call that D, is going to equal whatever forces I have acting down the plane. Okay, because they're balanced, because I'm travelling at that constant velocity. So I've now then worked out my driving force, because it's going to be equal to my resistive forces. Okay, once I've got my driving force, I can just go and use my F equals, oh, what am I talking about? My P equals FV. Okay, my force, my driving force is 164. The V is what I'm trying to find, equals my P. So let's just rearrange that. So they've told me they want me to use a P of 100. So I've got 100 over 164 equals my velocity when I rearrange that. And that gives me an answer of 0.61-ish when I type that in on my calculator. Okay, the last bit of this question is a written section of the question. So it says, explain how and why the maximum range of the wheelchair on level ground is affected by the mass of the user and the speed at which the wheelchair travels. Okay, now the maximum range must be mentioned in your answer because that's what it's asking about. Okay, so we need to get to the idea of how the range is going to change. Okay, and the way that I think about it is in terms of energy. So if I'm increasing the mass of my user, then I'm going to need to transfer more kinetic energy to it, because as mass increases, kinetic energy increases. Okay, so whatever energy my battery has to be transferred to the kinetic energy of the user in the wheelchair. So that means that a greater kinetic energy, so greater mass, means a greater kinetic energy of user and wheelchair will write. Okay, now what does this do? This means I'm draining that energy much quicker because I'm going to have to transfer more energy each second to keep it at the same kinetic energy. So that means my range is going to decrease. Okay, so maximum range will decrease as my energy per unit second is increasing, so my power consumption is increasing. Okay, then you've got the effect of speed. Well, it reduces the range because I know that air resistance increases with speed. So I'm going to have to do more work to overcome that air resistance, so my battery's not going to last as long. So it reduces the range because air resistance increases with speed. Okay, I hope that helped. I'll be posting another video tomorrow.